let's talk about a huge leap forward in manufacturing, one that's letting shops get way more productive. It really all comes down to controlling one simple but incredibly destructive force: vibration. We're going to get into how some seriously smart engineering is taming that chatter and pushing modern machining to its absolute limits.
All right, here's what we're going to cover. First, we'll look at the big problem with high-speed machining. Then, we'll dive into the physics of why things shake apart. After that, we'll check out the solution, see how it pays off in real money, and finally, look at how to tune the whole system for what is truly the future of manufacturing.
You know, the dream for pretty much any shop is high-speed machining. It means more parts out the door faster. But as a lot of people have found out the hard way, just cranking up the speed often leads to a whole world of new problems.
It's a really frustrating feeling, isn't it? You've got this machine that's capable of incredible speeds. You tell it to go faster, and what happens? Your tools wear out in no time, and your finished parts look awful. So, what is going on here?
So here's the deal. On one side, you've got the promise, just tearing through metal, boosting your productivity through the roof. But on the other side is the reality that's all too common. Parts with a terrible finish, tools breaking constantly, and even doing serious damage to the very expensive machine spindle.
And all of this, all these headaches, they all point back to one single culprit. It's that horrible, high-pitched scream you hear when a machine is really struggling. It's vibration, or as everyone in the industry calls it, chatter. And when you're going fast, it is an absolute performance killer.
Okay, so if chatter is the problem, what's actually causing it? To figure that out, we've got to dig into the physics of why a tiny, almost invisible flaw can turn into such a massive, massive headache.
It all boils down to this thing called tool unbalance. See, every single object that spins has a center of mass. Ideally, that center is perfectly on the line it's rotating around. But in the real world, nothing is perfect. There are always tiny little imperfections. At low speeds, you never ever notice. But once you start ramping up those RPMs, well, that's when things get pretty violent.
This is the absolute best way to think about it. It's all about centrifugal force. A tiny little imperfection that you can't even see is totally harmless when you're spinning slow. But when you spin it at tens of thousands of revolutions per minute, whoa, that small wobble turns into a powerful, destructive force that just wreaks havoc on your whole setup.
All right, so we know the problem. We know what's causing it. So, what's the fix? Well, this isn't about guesswork. It's about some really clever engineering, designed to bring back control and stability even at insane speeds. The answer, of course, lies in tooling that's built from the ground up to fight this very problem. These are not your standard off-the-shelf tools. They are manufactured to a completely different, much higher standard of precision, specifically for these high-speed jobs.
And if you remember one thing today, remember this: G2.5. It's the industry standard for high-performance, high-balance tooling. It might just look like a code, but what it represents is a serious commitment to precision.
So what on earth does G2.5 actually mean? Well, the G just stands for the quality grade. The 2.5 is the key part. It's the max vibration speed allowed in millimeters per second. So a tool rated at G2.5 is guaranteed to vibrate less than 2.5 millimeters per second, even while it's spinning at an incredible 33,000 RPM. That is stability by design. And you know, getting to that G2.5 rating isn't just one thing. It's a whole system. To balance the tool, they strategically remove tiny amounts of mass in just the right places. These tools are also designed to be used with really rigid, high-end tool holders. And they even come in specific lengths to cut down on how far the tool sticks out, which is another big cause of vibration. Okay, this is some seriously cool engineering for sure. But so what? Why does it really matter to a business? Let's connect all this precision to what every shop owner actually cares about: the bottom line. This is where that performance turns directly into profit. And the payoff is huge, and it's really easy to see. When you get rid of that violent vibration, your tools last longer because they aren't being hammered to death. Your machine's expensive spindle bearings last longer for the exact same reason, and that is a massive cost saving. You spend less time stopped and changing tools, which means less downtime. And, maybe best of all, you get better-looking parts right off the machine, which means less cleanup work later.
Yeah, this quote from the source material just nails it. It's a smoother process, a better product, and your expensive equipment lasts longer. It's really a complete win-win, the whole package. That's the real value here.
But hold on.
Just buying the fancy high balance tool isn't the whole story, not even close. If you really want to unlock what your machine can do, you've got to match that super precise tool with the absolute perfect running parameters.
And this is the real trick, isn't it? Every single machine, every tool, every holder, that combination has its own unique personality, its own dynamics. The speeds and feeds that work perfectly on one machine might create terrible chatter on the machine sitting right next to it. So how in the world do you find that perfect sweet spot?
The secret isn't trial and error. It's not about guessing and hoping for the best. It's about data. And you get that data by using a really cool diagnostic system called a tab tester.
The way this works is actually fascinating. First, you literally tap the tool with a special little hammer to make it vibrate. Then, sensors measure both the force of that tap and how the tool responds. All that data is used to create what's called a frequency response function. Think of it like a dynamic fingerprint of your specific setup. That fingerprint is then analyzed to generate a chart of the absolute best speeds and feeds and cut depths to avoid vibration and just get the most out of your machine.
Okay, let's put all the pieces together, because this is where it all clicks. Having a precisely balanced tool, that's the foundation. And using data from tap testing to find the perfect parameters, that's the key that unlocks its potential. When you combine them, you see that the future isn't just about going faster. It's about moving smarter. It's a huge shift from brute force to precision control.
And this is the big takeaway. Next-generation manufacturing isn't about having the single fastest machine. It's about creating a fully optimized system. A system where that G2.5 tool, the rigid holder, and the unique dynamics of the machine are all understood and tuned to work in perfect, chatter-free harmony. That harmony, that's where you find the incredible metal removal, the amazing surface finishes, and true, honest-to-goodness efficiency. And that leaves us with one final thought. Just trying to run faster without thinking about balance and the dynamics of your whole system, well, that's just a recipe for frustration. So the real question you have to ask is your tooling ready to stop fighting against physics and start working with it?